small session, 45 minutes. It's also very early in the week. I personally see this session more as an orientation session for you going forward. So I'll just show you very briefly all the different components and what can be done. And then at the end, I will have a number of sessions to redirect you if you want to go further, either on the hands-on, either on the edge compute, either on the cloud platforms, or anything like that, okay? So that's really a first approach to Kinetic. Does that make sense? Great. Small introduction, then we'll be talking about two starter solutions. So starter solution is something we have to get you started in no time. It has all the Kinetic software and some pre-made templates, so I'm going to talk about that. Some of the real use cases we have done, where it's really working, what customers are asking for, and things you need to be aware of. Then I will have some orientation about what other Kinetic sessions you can go to, and workshops. So we have traditional sessions, DevNet sessions, and workshops. Workshops are hands-on. And I would like to give some time here for questions and interactions, so feel free to interrupt anytime. This is not a keynote, this is DevNet, so it has to be very informal, ideally. All right? So who knows about Kinetic already? Just to give me, all right, let's say 20%. So let's do an introduction. I think the next slide is going to be very important because Kinetic is not like any other Cisco product. And I'll tell you why. When you typically buy a Cisco product, be it a firewall, be it a router, it's just like one finished product. You get it out of the box, you have a manual, you configure it, and it works. Kinetic is not really like that. Kinetic is a set of software. So you have many different components that you may or may not use. They may work together or they may work independently. And if you decide to have them work together, there's different ways they can interact with each other. So I don't like to talk about Kinetic as a platform. I know at Cisco we really like the word platform. I don't think that's really a platform. I don't think that's a product. That's just a set of software. And also hardware, because the software runs on the hardware, but that's a set of software and hardware working together. And that will enable you to create a distributed platform to acquire data on the edge, extract, compute, and transport this data. Okay, so I want to spend some time there because that's very, very important. Don't expect a turnkey solution. And let me turn off the slides. Don't expect a turnkey solution. It's not specific to Cisco. As a matter of fact, there is no turnkey solution in IoT really. And those who say they have turnkey solution is because they have like point products. That exist. I have a Nest thermostat at home, for example, where I can set the temperature and everything. This is IoT, I agree. This is very simple to set up, but it just does thermostat and nothing else. You don't have this flexibility that you have with Kinetic or other of those solutions. So that's really what I mean here. So we really rely on partners and customers to build a solution based on Kinetic. And that's why the Kinetic sessions are typically not breakout sessions, but they are mostly in the DevNet zone. Because that means, DevNet means you gotta do something with it. It's not plug and play. All right? I hope that makes sense. If not, let me know. So what do we have here? On the left side, and the typical architecture we have, on the left side you have the sensors. It's always like that. The sensors are connected to the network. The network will transmit the data somehow to Kinetic. This is just a sample architecture, right? This is not always the case. But the network will transmit the information to Kinetic, and we're going to talk about what Kinetic really is all about. And then Kinetic will send that information either to a public cloud, to private cloud, or even to another Kinetic node. You can stack Kinetic nodes on the top of each other. This network can be a very traditional network, or it can be Jasper if you want to provide SIM card-based connectivity, or it can be LoRa, or it can be Zigbee, as a matter of fact. It can be a lot of things. I mean, if I want to put everything on one slide, it's just going to be a little messy, so we decided to make it very simple here, right? The fundamental behind all this is security. The security is fundamental in everywhere at Cisco. We now have intent-based security for IoT, and there is a number of sessions talking about that. I don't think we're going to address security in this case. I just want to make sure we focus on the edge processing. Kinetic, the Kinetic component does basically three things: extract, compute, and move the data. What does that mean in practice? Extraction. Typically you have sensors, vibration, temperature, humidity, presence, field waste, whatever. You have those sensors, and you need to acquire information from those sensors to do something. This is the extract. The extraction for us is performed at the protocol level, right? So we talk a certain number of protocols, and I will explain how it works, and we extract information at the protocol level. Every day, someone asks me this question: what sensors do you support with Kinetic? This question makes no sense. We do not support sensors, we support protocols, right? So a sensor has a protocol, and this is the protocol that we do support. What's that?
On Ethernet and field buses as well.
Yeah.
Protocols on Ethernet.
Protocol, well, Ethernet, so the question is Ethernet as well.
Or field buses, or what are the...
So field bus, for example, yes. So BACnet, LoanWorks, Modbus TCP,
Thank you.
MT Connect. And as a matter of fact, I'm always saying for us, because we integrate at the protocol level, Twitter is a sensor for me. YouTube is a sensor. And we actually have modules that you can plug and watch the number of views on a video on YouTube and use that as an input for your edge logic. We have capability to talk to a Hue, Philips Hue lights. So you could say with Kinetic, you could just turn a Hue light in red whenever someone likes your video on YouTube. Is this really IoT? I'm not sure, but I mean, I'm just saying, for us, we integrate at the protocol level, and what is important is just the data. If you have sensors that do not talk any protocol, like for example, a door contact, it's open or closed. Well, then you have to plug this one into a gateway that will transform that into something we can understand, like a Modbus TCP gateway. If you come by the Cisco booth, we have that. Okay, so let's go back here. That's the extraction. Computation. Whenever you receive data on the edge, you can compute data over there. Computing means a lot of things. It could mean storage, average, filtering, throttling, transforming, whatever you like to do, but this data will be transformed or can be transformed in the edge. Classical use cases, fridge monitoring. I'm monitoring a fridge temperature. It's okay if we are between 0 and 3 degrees. And I'm doing this monitoring every second. Do I need to send data every second to the cloud about the temperature of this fridge? No. I just can send a message every half an hour and say, I'm still there, I'm still monitoring the fridge, and it's below okay. For the last half an hour, average temperature 1.5 degree. If you're below or above that threshold, then you start sending messages immediately. That's a very simple example on how you can do filtering in the edge, okay? Which is exactly the purpose of the Kinetic software. And then lastly, you move the data. Once you have the data and you have filtered or transformed the data, you need to move it to its final destination. Usually, you don't leave the data at the edge. You move it either to a public cloud or private cloud or data center application, whatnot. Okay? That's really what we do. The components, so that's the three main functions. The components we have within Kinetic, and I'm really sorry for those acronyms. It took me a while also to get used to it, but that's fine. We are in IT, we should all used to it. The three main components of Kinetic I'll call GMM, EFM, and DCM. GMM is the Gateway Management Module. Think about it as a network management system. Okay? I want to go as far as saying this is like Cisco Prime, but I would probably go as far as saying this is a little bit like the Meraki cloud platform, but for iOS routers and IoT gateways. The next component is really the one that does the processing at the edge, called, unsurprisingly, Edge and Fog Processing Module. Okay? GMM's cloud-based, EFM is software that can run on Linux or Windows or Mac or Raspberry Pis that can run in a Docker container, or that can run on some of the Cisco platform, IR 807, 809, I'm sorry, 809, 829, and the new IR 1101, and the IE4K. The last module is called, the last module here on the right, data control module. Think about it as a router for your data. We're not routing packets, we are routing information. So we're taking information from the sensors, we're writing rules, and we say, well, this information, we throttle it, and then we send it to Microsoft Azure. That information, we don't want to send it to Azure, we want to send it to IBM Watson. And the connection has been made between DCM and those different platforms already. Okay? Let's go into some of the details. Let's talk about GMM. So GMM, cloud-based platform. If you think about Meraki, that's kind of how it works. You take a Cisco IR 829, you claim the serial number, you plug the gateway to an internet access, whether it's a SIM card, whether it's using gigabit Ethernet, it doesn't matter. And that's it. The router is auto-discovered, calls home, is provisioned based on a template, and you can configure almost everything from GMM, right? So you can monitor your gateway, you can see where it is, because those gateways have GPS location, so you can do geofencing. You can push IOX applications, you can push applications on the router, okay? So you really get started in no time. You can enable Wi-Fi, you can, I don't know, you can enable a specific subnet behind the 829, you can configure DHCP if you want to, etc., etc. So really the idea here is to do network management for the gateways. Why is it important? I also have often these questions. Customers are saying, oh, I have Cisco Prime, why do I need GMM? Well, if you have Cisco Prime, that's perfect, keep using it. GMM addresses a complete different use case. Think about police cars. We got the county of San Antonio in Texas. They are running 829s in police cars, connected with 4G. How do you manage gateways in a police car in a secured way? Not with Cisco Prime. This is an enterprise network platform. And those routers are installed in cars with police officer. These guys are not IT people. You want to be able to send them a router that they onboard it to the platform and they don't have to touch anything. Actually, you don't even have access to the CLI with GMM. So that's really for this kind of highly distributed, remote, or moving platforms that GMM really shines. All right, that's the first component. Next component is EFM, Edge and Fog Processing Module. That's really the brain that sits at the edge, which connects a variety of devices, as I said before, at the protocol level. What is really important when we talk about protocol level is to know what is a DS link. A DS link is a plugin that you can install inside EFM that is written using an SDK, and this SDK is publicly available. If you go on Cisco DevNet, you can download the SDK and write your own DS link. This DS link will enhance the functionality of Kinetic EFM. So we have DS links, as I said before, we have DS links for Philips Hue, we have DS links for Twitter. We also have DS links for Modbus TCP, we have DS links for MQTT, we have DS links for REST HTTP APIs, for example, etc., right? So we have a repository of about 100 different DS links, and all those DS links can act as an input or an output for your logic. All right? And then you can build your own. We are working with Penduit, and I will be talking about them in a few moments. Penduit, doing the racks and everything. And they have also a number of sensors coming from an acquisition they did years ago called SynapSense. Penduit is developing a SynapSense as the DS link for EFM, so that you can use directly their gateways directly into EFM, because they're using a proprietary protocol. There is nothing else we can do. Okay? So once the DS link is in there and you enable those different protocol support, then you can create the logic. The logic in EFM is not written in any language. It's a visual language. You take blocks and you connect blocks together to create logic. So you do not have to be afraid by the syntax. You do not have to be afraid by the language. You just need to know what you want to do logically. And then you group the logic blocks together. I'll show you how it looks like. All right? EFM, and I know it's it's sometimes extremely confusing, but EFM can run on some of the router. I want to repeat that because that's important. EFM can run on the edge-enabled routers, 809, 829, IR1101, IE4K. It can also run on a Docker container. It can also run on Linux. It can also run on Raspberry Pi. So we have different distribution. Raspberry Pi is not officially supported though, but we have it. So we have a number of different distribution channels for EFM. So it's not very specific to the router, but it's very useful to run it on the router when you have it, because that's really what delivers this edge computing picture and story. Inside EFM, we also have a database called ParStream, which is a Cisco acquisition from a couple of years ago. A very high performance streaming database, which is part of it. We have some visualization capabilities in EFM. I would say it's there for you to play with, but I would not recommend to use that in production. It's not made to scale. It's made to make a few graphics here and there, but it's not made to scale. If you really want to do something visual globally, use something different. All right, and then there's DCM. I've been talking about DCM, the data control module. It's a routing for your data, sensor data. So your sensor data actually comes into Kinetic, which is a data fabric, and from there, we have a number of things we can do. On the upper side, including this policy-based routing. That's the same name as Cisco iOS, policy-based routing for IP packets, but here it's policy-based routing for your IoT data. All right, so you can decide to send information to Microsoft Azure, to IBM, or to both. Again, it's an optional component. You don't have to use DCM, you can use DCM. So, I hope you understand what I said at the very beginning. It's a set of distributed software. You can't really use everything. Or you can use EFM in different ways. You can run it on Linux, you can run it on router. I know it might be sometimes a little intimidated to get started because of that. So we created two starter solutions for you to get you started quickly. One of them is specifically oriented on energy management, and the other one on equipment health monitoring. So what is a starter solution for you? In my business unit, we define that as a product, quote to quote. It's a product in the sense it's all made to be working together. We package everything, the software, the licenses, the hardware, the sensors, we package all that under a single SKU. The solution is complete, it has been pre-configured. We give you an OVA that you can install that has everything pre-configured in there. You have all the DS links that are already there, the templates, the dashboards, you have the hardware, you have everything. Okay? Purpose is that we say it can be implemented in 2 weeks or less. Usually it's more like half a day, but anyway. Very short, because everything has been pre-configured. It's almost plug and play. It's a fixed scope definition. If you buy a solution for energy management, it does only energy management. We have software license for 6 months. It's based on all the Kinetic components that we've been talking about, right? I want to say, well, this is irrelevant here, but what I want to say is the starter solution is not meant to be run in production. It's really something to get you started quickly. It's a POC in a box, if you wish, right? And you can purchase, or you can not purchase the hardware. That it is up to you. If you already have the hardware, you can just buy this kit and use your hardware, or you can buy the hardware on the top of it. It really doesn't matter. So the first one is on energy monitoring. What we do with this one is coming from the traditional, I have a factory floor, I have equipment, and I don't know how much energy is consumed by all those different equipments. Those equipments can be CNC machine or anything like that. So what we do is, the typical approach is to add energy monitoring on top of those machines without disturbing the machine way of they are working. We add energy management on the machines, we connect all these energy management systems together, and then we bring this information all together in a reporting platform. All right, so the idea is really to monitor energy usage and report on energy usage in a single dashboard. So we have single and three-phase meters. So how does that work in practice? We acquire energy usage, oh, I'm sorry, wrong button. We acquire energy usage using, I'm going to talk about how it works, but it's basically energy measurement system that does not require to cut wires. Those systems are made by a company called iSockets, and the gateways are talking MQTT. So we use Kinetic on the edge to receive MQTT data from the different gateways. We aggregate information over there. We do this polling every second. So obviously we do shaping, averaging, we make a total usage of the energy information, and we report that over a graphical interface over here. You can create 3D dashboards with your views if you have it, and then you can simply take the values and drag the values on the floor plan, for example, so that it looks better. Since this is based on EFM, you have the data flow editor. I'm going to talk about that exactly, but this is how you program the functions on EFM with a flow editor like this, which is a little bit like Node-RED, if some of you know that. Right? And everything has been pre-installed and pre-configured. So how we do the energy measurement is with this iSocket thingy. We use what is called a Rogowski coil, which is basically just electromagnetic measurement field that you wrap around the wire. It looks like this. You wrap it around the wire, measures the electromagnetic power on the wire, and since we know the tension, we also know the power, and then we can calculate how much energy is actually drawn on the single phase. We have 3 of them for 3 phases, and then we can have the total power. All right? So because you clamp this around the wire, you don't need to cut the wire, or you can even remove the system to another machine if you want to. That's why we choose this solution. Is it the best one for a production system? I'm not sure. But for a POC, I don't think there is any better choice. All right? So this is how it looks like. So we have a number of single phase, multiple phase. This is how the gateway look like. We also have a number of other things that you can add if you want. Thermal sensor, and we have a flow sensor for liquid. Typically, we're going to be using flow for cooling systems. So we are measuring the delta of temperature between input and output, quantity of water that goes through the cooling system, and then we can calculate the BTU of the cooling system, which is, and then its efficiency, because we also measure power usage. So you have BTU, power usage, and then you can measure efficiency of systems like that. Okay, this is a box with all different sensors and one gateway all together. This is really how it looks like when this is finished. All right? So we've been doing that with one of our customers in Taiwan. The project was great. I mean, we had 250 on those boxes deployed everywhere on all the manufacturing plant. The advantage for them now is they can see where the energy is being wasted. For example, when there is nothing that is being produced, they can look at this period of time where nothing is produced and how much energy is wasted by all those different machines, and they quickly realize there is a few things that they can optimize. Not changing the machine, but optimizing either the process or the way they manage things. So this is where we really find most of the time the business outcome for IoT. This is by changing the process. Same story, so you can see, once again, on the upper left side here, you have the energy measurement system, and this is for compressors. And this is really, on the bottom here, how those things are being installed. Don't do that yourself. Ask an electrician to do that. It's just my recommendation. We had problems, so. Sure.
Can you do that with an ordinary power cord in the office environment?
So the question is, can you do that with a corded power cord in the office? Yes and no. You cannot, because if you have a power cord, let's assume this is a power cord, all the wires are together. So the electromagnetic field on one way will be compensated by the field coming on the other way. So the net result is always going to be 0. So you have to isolate the phase. What I have is I have things like this, where I strip down the isolator on one portion of it, so I have the 2 phases that are separate. But then you need to cut the power. Replace the cable and use that on the cable. The other use case we have, let's go really quick on that. It's built exactly the same way, except that we're not looking at energy usage, we're looking at predictive maintenance, equipment monitoring. It's a very hot topic in the industry for years. often I make this analogy with my wife. I'm talking about my wife, it's getting serious here. My wife, she's not an expert in cars, right? But she's got a car like all of us. And sometimes she tells me, honey, I don't know what's going on with the car, but I feel like on the steering wheel there's something weird. It's not as usual. I say, yes, honey, that's because you have a flat tire. So she doesn't know exactly what the problem is, but she knows that something has changed and it's not quite as usual. With the equipment health monitoring, it's exactly the same thing we do. We monitor operational parameters of machine, and we tell you, or we try to tell you, when something has changed. Maybe that's okay, maybe that's not, but it's up to you to perform the next investigation. It's a way cheaper alternative rather than doing a full instrumentation on all the machine all the time. So that's the fundamental idea between the equipment health monitoring. We use the exact same structure with sensors at the edge, with EFM aggregating the data. This should look familiar. The only difference with the previous solution is the type of sensor. Here we are using wireless sensors. When you install sensors on a machine, a real machine that moves with chariot and elevators and everything, you don't want to have wires. So this is a complete wireless sensor solution made by Panduit that we integrate with. So you got sensors and a gateway, talks to EFM, and then we have everything pre-configured for you in this solution. All right, couple of sensors, let's not go into the details. The range is about, I would say give or take, 150 meters, sometimes more, sometimes less, depends on the RF conditions on site. And those sensors are battery powered. Battery lasts very long, very, very long. And you need one gateway for 100 sensors, so you have a scalability there. Once again, does that mean you need to put plastic sensors like that in production on the line that manufactures cars? No. There are other vibration sensors for that are very industrial. But this is perfect if you want to build a use case or if you want to monitor something else. We have customers that put those sensors on a coffee machine, so they know when people are pouring coffee. And they assume that when you pour 6 coffee out of the coffee machine, the coffee machine needs to be refueled. You know, some people have a lot of spare time. Okay, we deploy this at a German manufacturer. This is a mock-up of a machine. As you can see, we have sensors. Sensors are actually wired over here. So we can monitor the amount of time the arms are in motion, for example, because there is a gyroscope in there, the average vibration, dominant frequencies, and things like that. If you see that, generally speaking, it takes 20 milliseconds to do a movement, and suddenly it's 21, 23, 25, I bet something needs to be lubricated somewhere because it's not really moving as fast as usual. Just an idea. Okay, some installations on better, bigger machines. So one of the lessons we learned, any questions on this before I keep moving? All right. So based on all those projects, we did one of them with a US company that also manufactures power outlets and things like that. And they had a network in place, and what they really wanted to do is, they wanted to know how much energy was spent to manufacture a specific product. So there was a lot of data acquisition to be done on the edge. There is the PLCs that control the robots that we need to acquire information from. There were sensors that we install on machines to gather other information, and those sensors, we could not choose them. They were selected by the customer. As well as the gateway, not our choice. So the reason why I'm saying all this is, I have never seen so far an IoT, a real production IoT project where you got to choose what you work with. Usually the equipment is already there, it's not your choice. And the reason why I'm saying this is, when you start an IoT project, start with a platform that you know can scale and can support a lot of different things. If you start with a point product solution with a very narrow scope, like for example, I can just do a PLC integration. If you do something that is not PLC integration, then you're going to end up with silos. you can end up with one application to do something, one application to do something else, which is exactly what we don't want. We want everything to end up at the same place. Okay, so in this case, we had the PLC integration. We did not have a DS link that supported the PLC directly. So when we use Kinetic at the edge and we do not support the PLC, there is always a solution. We have partners that we can partner with, and these partners implement solutions to augment the functionality on Kinetic. If you go on our Cisco booth, we have a couple of them that we can show you, but in this case, it was Telit. So we run the Telit software right next to Kinetic EFM on the IE4K. The Telit was actually getting information from the PLC, converted to MQTT. We got the information from MQTT and send it to the cloud. Okay, so we can build solutions like that. Once again, remember when I told you it's a set of distributed software. You don't always use Telit. Maybe you do, maybe you don't. But based on your specific solution, you pick the components and you create it, which I think is what is very exciting in this place. So eventually the data went through DCM, Data Control Module, remember we talked about that, and route the data to Azure IoT Hub where we did all the visualizations. And if I remember correctly, I think we used Power BI for that. Cisco doesn't do any visualization platform, so we are totally agnostic in that. We don't do the sensors, we don't do the visualizations, we don't do the analytics. But we do everything in between. Something that I believe is extremely important is data models. I can't remember how many times I've seen IoT projects where what you end up with is a bunch of unstructured data that is a total mess and it's impossible to use. Because depending on the type of sensor, depending on the protocol, depending on how you send it, you end with different information. Some of them come in XML, some of them are in JSON, some of them have degrees Celsius, some of them have a raw reading on a sensor that does not even translate to anything, and you need to apply some transformation. Example, you have a gauge, for example, that gives you value between 0 and 65,535, depending on the height on a reservoir or a tank. 32,000 doesn't help me. What I need is the number of liters in that tank. And I need that information everywhere, and I need that information to look the same way. So process the information early and process it to be compliant to your data model. I don't care which data model you use, but just pick one and use it. I'm not religious about data models. I'm just giving you an example, though, of SenML, which is currently being ratified at the IETF. It's very simple, it's JSON-based, it's self-descriptive, and it's very compact. It might not be compact enough for some cases. If you use LoRa, for example, and your payload is maximum 50 bytes, this is just not going to work. You have to be even more compact and use binary encoded values, for example. Or if you don't care about compact, well, use XML. And you have a file like this. With SenML, it's going to be like this. And with CBOR, which is binary encoded, it's going to be 3 bytes. I'm not religious, but just take one and stay with it, for this project at least. And naming conventions, that's a good one. And again, I don't remember how many times we've seen simply location information to be totally inconsistent in the project. So you end up with a complete mess, or you don't know where the machine is, you don't know which machine the sensor is connected to, or they have even 2 different naming conventions. There is nothing you can do with your data if you are not tag your data properly, or if you don't use data model properly. And maybe this is going to be easier early on if you don't do this work early. But it's going to be a lot more complicated later when you will have to do analysis and everything is a mess. So do that early, do that at the edge. All right. Another use case we had is a company called TellMe Plus. It's a French company, and they're building models that they call predictive objects, which is basically machine learning modeling. This machine learning model, I'm not going to extend on that, but it's mostly for predictive maintenance in the aerospace sector. What we built together is they wanted to instrument the truck. We didn't have the real truck, so we used a toy truck for that. We instrument the truck with a number of sensors, and what they really wanted is to put the router inside the truck, and the truck to be totally autonomous, be aware of its environment, and take local decisions. So we had tilt, inclination, vibration sensor. We have flashlights on the top of it, and we decided to turn on the flashlights whenever a certain number of conditions are met. All this logic is pushed on an A29 that runs the FM. All that logic runs over here, receives the sensor value, turns on the flashlight, but the programming is made from a central platform, which is what we call EFM admin. So that's the administration interface, the graphical interface, and in the router there is only the broker. So the broker does the compute, and this is the human interface to program the compute, okay? So from here, you write the data flow, and I'll show you what the data flow looks like. You write the data flow, you can see it here live. You can see the values. If I'm shaking the truck, I see the values of the vibration sensors changing over here because they are streamed in real time from here to the admin platform. Every time I change something here, it's instantaneously executed on the compute platform. And if you lose the connection here, for example, if this truck goes into a zone where there's no network coverage, no problem. It will keep on acting locally because the program in the broker runs autonomously, and when we get the connection again, we will stream all the data that we have missed. Because we have a queuing system, which is part of the MQTT and AMQP protocols we use. We can queue messages. We can drop them if you want, but we can also queue them up until the connection is reestablished. Okay? And this is really how a data flow really works in this case. So with the value from the accelerometer, we have some reference value here for inclination. We have distance sensor that gives you the distance from the closest wall. And then we have some 2 if logic blocks. If this, then that, if this, then that. And if those 2 if are true, then I'm doing something. In this case, I'm publishing an event on MQTT. And by publishing the event on MQTT, it goes back to the truck and turns on the flashing lights. If you're interested about this, stay tuned. We have a session here in DevNet where you will be able to program on a Raspberry Pi with a data flow like this. I think it's tomorrow. Anyway, I'll give you the session number. Okay? Questions on that? All right. We have 5 minutes left, so it's about the time for me to... I hope you understand what Kinetic is all about. This is probably a little fuzzy. That's okay. It's a fast overview. We went over some of the solutions, what we did, what it can do, the different components. But as I said at the beginning, this is more an orientation session for you to continue. So what we have a specific session here on DevNet to manage the edge compute with Kinetic. So that's really a DevNet session like this one, but I will talk just about the EFM component, which is the edge compute. So it might be interesting for some of you. We have a session here which is more about how to use the data with machine learning. How do you do with the data? How do you process the data? How do you store the data? What can you do with it? So we're not, in this session, we're not talking about edge compute at all. It's totally on the other side, data center. Well, we got all this mess of information. What value can you take, value can you make with all this information all together? We have a session which is specific on LoRaWAN. I don't know if for those who are familiar with LoRaWAN, that's great. I love it, it's my baby, I love LoRaWAN. For those who do not, it's a long-range, radio-powered transmission technique that works with gateway and network sensor, a LoRa network sensor, and a network server, there we are, a LoRa network server. The advantage of LoRa is that it has a very, very long range, multiple kilometers. It's very, very low power. With a single cell lithium battery, you can last for 10 years if you send just a couple of messages a day. So there is a number of various, very interesting use cases for smart cities and things like that. So that's a session by my colleague and friend, Patrick. We have one session specifically talking about what are the wireless technologies that we use in the industrial IoT space by my colleague and friend, Marcus. One session specifically about what is IoT going to look like with 5G. You know, there is a lot of discussions about LWPA, like LoRaWAN, 3G PP, 5G IoT, NB IoT. That's going to be the session for that. So that's IoT connectivity mostly. All right, so there is one session specifically about blockchain, buzzword of 2019, but still, if you want to hear what we can do with IoT and blockchain, I think that's the session to go with my friend and colleague, John. And then the last one is going to be management and deployment of scalable solution with IoT routing, so that's going to be all about our hardware platform for IoT. 807, 809, 829, R1109, all the IE, IE2K, 3K, 4K, IOX components and things like that. Very hardware. In terms of hands-on,